All right, welcome back to Distance Learning Land. We are today looking at Lesson 81. Lesson 81 is this idea that we're taking a look at molecular views of what a solution would look like. Again, a solution, we take a substance, we put it into water, and it dissolves. Generally, it dissolves completely until we reach a saturated solution. Again, this is something you should have seen in your lesson 80 notes. But if we were to look at it molecularly, down to the particles themselves, essentially what we'd see is if we had something like a 1 molar solution. That 1 molar solution might look something like this. It's got a bunch of little tiny particles all over the place in there. And inside any given square or chunk of that solution. So let me see if I can get my finger, that little square that's right there, that little chunk of the rectangle, that is exactly the same as all the rest of this stuff. So that picture, if I was to pull that out, it would still be 1 molar of solution. It would just be a smaller amount. Well, because it's a smaller amount, now there's not the same amount of moles. If this whole contraption, this whole box was 1 liter, then there would be 1 mole of particles, 6.02 times 10 to the 23rd of whatever we put in there would be in there. But if I took out this little chunk right here, okay, that might be a quarter of it. Now I've got a quarter of a mole in that one little chunk. I've got maybe 250 milliliters in that little box, and that 250 milliliters being 1/4 of a liter, if it's 1 molar solution, then it would have 1/4 of a mole in there. Now, if I look at the other box here, this guy here, this is maybe a 1/2 molar solution. And so what that's representing again is if there's just fewer dots. I didn't count exactly that there's half as many dots in this one as there are in that one, but you should get the point that, okay, there's definitely fewer here than there are over there. Again, if I took a little box out of this one, if that whole thing was 1 mole, then there would be 1/2 mole of the substance if that was 1 liter inside of that box. So anyway, let me pause this real quick. And we're back. And the idea today is that the math, again, is not too difficult if you understand the molarity equals moles divided by liters. So molarity, that big M we saw yesterday or in the lesson 80, that's moles per liter. So the idea of today's math type questions is how many moles of a particular substance would be in a certain amount, a certain volume, if we knew its concentration. And so these types of problems are relatively easy as long as you remember this guy right here. So today, what we're looking for is that mole right there. And to do that, there's a number of ways we can do it. My personal preference anytime I'm doing math is I want to solve for what I'm looking for before I ever start with numbers. Some people, they like to jump in. They like to throw that 52 milliliters in for the liters right away. They like to throw the 0.5 molar solution in for the molarity right away. You can do it that way if you want, but I like to show the math behind it first, and that way, it doesn't necessarily give me another formula to memorize. All you got to do is remember one formula, but you have to figure out how to algebraically manipulate it. And once you know that, it's just like taking A equals B over C. What's B got to be? Well, it's got to be A times C. And so basically, we want moles by itself. So what we'd want to do is we'd want to multiply by liters on both sides. That's going to give me moles equals molarity times liters. And then the only thing we really have to worry about at that point is what's going on with what's given. Okay. Here, I'm given 52 milliliters. So I can't just take 52 and plug it in there because it's milliliters and not liters. So I've got to go over here. I got to go 52 milliliters, divide that by 1,000 milliliters per liter. Again, the milliliters cancel. 1 over a liter is a liter, and 52 divided by 1,000 is 0.052 liters. So that 0.052 goes here. Then the molar solution, the molarity needs to go in here. So that's 0.5. We have to remember what molarity means. It's moles per liter, and that way the liters cancel out. And once we have that, 0.5 times 0.052 is going to be 0.026 moles in that particular solution. Now, in lesson 82 coming up next, we're going to see that there's another way to write this question, and it's how many grams. Okay, so how many grams of sugar, blah, 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 blah. It's basically the same exact steps, except for right here, you end up taking a look at the moles, and you have to multiply by the molar mass to find the number of grams. So how many moles of sugar are in 26 milliliters of a 0.5 molar solution? 26 milliliters divided by 1,000 milliliters per liter is going to give me 0.026 liters. Again, I multiply that by half a molar solution, so times by 0.5 mole per liter, and that gives me 0.013 moles for my answer. And so that takes care of the check-in. Sorry, I forgot to talk about the opening part, the chem catalyst. All right, so the chem catalyst in lesson 81 was again about our grizzly bears, our gummy bears. But the gummy bear question was, you take the gummy bear, you throw it in these different solutions. How can you tell what's going on and whether or not you have a saturated solution? Well, basically, a gummy bear is saturated with sugar. You can't put any more in there. If you could, essentially what you would see is that it would shrink. Okay, and that's what it does in the corn syrup, which is a saturated solution. When you put the gummy bears in the other one, they kind of swell up. The reason that they're swelling up is through osmosis, there is water that is making its way through that semi-permeable membrane of the gel that makes the gummy bear, and it helps to swell it up because there's less sugar in the water. The water works its way into the more sugary gummy bear. And again, the process is to make them try and equal out how much sugar is in both places through concentration. And then their last two questions was, you've got the big container, 1 liter, that's 2 molar, and then you pour 100 milliliters out. Question 3 is, did the concentration of the sugar in the large container change? Concentration didn't change. I demonstrated that when I was talking about, I take out a little chunk from my diagram there. It still stays at the 2 molar as far as the chem catalyst goes. Now, 4, did the number of moles of sugar in the large container change? That absolutely did change because we took a chunk out. There is no longer the same number of moles that was there to start with. So I hope that helps you through lesson 81. I should be getting out lesson 82 and 83 here shortly. But if you have any questions, again, tuyrick at auhsd.net.